Question number 13 deals with the angle of contact and phenomena of capillarity. If you have observed, if you have a straw, you place in a cold drink, the water rises above. This phenomena is known as phenomena of capillarity. And the tube is known as capillary tube. By knowing this angle of contact, we can find out a relationship with the phenomena of capillarity also. So first part is what is angle of contact. A part deals with the angle of contact. Suppose you have a tube you place it in a liquid, say in this case water. As you have observed for a straw in a cold drink, the cold drink moves up. So the water won't be at this level, water will move to a new level. And at the top you observe this curved surface. Now we want to define what is angle of contact. At this point, you draw a tangent to the liquid surface. When you draw a tangent to the liquid surface, you find an angle inside the liquid, not outside. Angle between the glass, this surface, and the tangent inside the liquid is known as angle of contact. For certain liquids, this theta is less than 90. For the liquid where theta is less than 90, this liquid will move upwards. So, what is angle of contact? Angle of contact between a liquid and a solid is defined as angle enclosed between the tangent to the liquid surface at a point of contact and the solid surface inside the liquid. Remember this, it is inside the liquid. This angle is suppose 60 degrees, then this angle is 120. It is not this angle, it is not this angle. It is not outside, it is inside. So, I repeat, angle of contact between a liquid and solid is defined as angle enclosed between the tangent to the liquid surface at point of contact and the solid surface inside the liquid. B part. Factors on which angle of contact depends. One by one. It depends upon the nature of the liquid and solid in contact. Depends on nature of liquid and solid in contact. I repeat, depends upon the nature of liquid and solid in contact. In this case, it is what? Liquid is what? Water. Solid is what? Glass. So, it is water and glass. So, it is a pair property. 1. 2. It depends upon the medium which exists above the free surface of the liquid. Medium which exists above free surface. Yes, in a room, free surface of a liquid. Yes, what do you have here? Yes, air. So it also depends on this. 3. Independent of inclination of the solid to the liquid surface. Does not depend on inclination of solid surface. What does it mean? It means whether you keep the pipe vertical or incline it at certain angle of contact remains same, does not depend on inclination. 2, 3, 4. It is fixed for a given pair of solid and liquid and surrounding medium. It is fixed for solid, liquid and surrounding medium. Yes, in the given example, solid is what? Glass. Liquid is what? Water. Surrounding medium is what? Air. So, we summarize B part. Depends on nature of liquid and solid, water and glass. It depends on this part. Depends on the medium, that is air. If you combine 1 and 2, it depends on liquid, solid and medium. Fourth point is depends on solid, liquid and medium. So 1, 2 and 4 means the same. For this example, water, glass, air. 3 factors will decide angle of contact. Does not depend if you change the pipe capillary at certain angle. If you change this angle of contact remains the same. Time with you is 4 minutes to write this. C part. Question number 13, C part deals with capillary tube. A straw. You can see a straw. A pipe with a fine hole, uniform hole. Fine uniform hole throughout is termed as capillary tube. So straw is an example of a capillary tube. So what is a capillary tube? I repeat. A tube with a fine and medium bore throughout its length is called a capillary tube. The diagram is same. If you have a tube, straw, this is straw. Place it in a liquid, this liquid moves up. This phenomena is a phenomena rise of liquid above or below the surrounding level is phenomena of capillarity. Examples and applications. Number 1. The fine pores of blotting paper act like capillary tube. Ink rises in them, leaving the paper dry. If you have a fine paper like this, blotting paper, if you have a blotting paper, you have a fine pores. Fine pores in the blotting paper act as capillary tubes. You can perform an experiment. How? Take a piece of paper, blue color ink, suspend this piece of paper using a clip here in a blue color ink. What you observe is, after some time, this blue ink moves upward. Why? Liquid moves up in a fine capillary tube. So, this is what a blotting paper. This is ink. This is a blotting paper. Example number 1. Rise of ink in a blotting paper. First. Second, a towel soaks water on account of capillary action. Towel, if you perform the same experiment, replace this paper by a towel, place ink below this, ink will also rise up in a towel. Towel soaks water because of fine pores. So, towel. 3. Oil rises in a long and narrow space between the threads of a wick because they act as fine capillary. Cotton. This is cotton. Surrounding the cotton, you have oil. And you have a flame here. How this flame can continue with time? Yes, because in cotton you have a fine holes, fine pores, so oil moves upward through these fine holes. So 3 is what? Oil rises in a wick because of a, yes, this phenomena is again phenomena of capillarity. 3. 4. Swelling of wood in rainy season is due to rise of moisture from air in the pores of wood. Yes, in a log of wood. Water rises because you have what? Fine pores in wood. That also acts as a capillary tube. 5. Plowing of field is essential for preserving moisture in the soil. By plowing, the fine capillarities in the soil are broken. water from within the soil shall not rise and evaporate off. That is, in the field you have these fine pores, and water keeps on moving through this and gets evaporated. So there is a loss of water in the soil. By plowing, by mechanical device, a tractor arrangement, by plowing the fields, you break this. When you break these capillarities, now capillary action won't take place and this water is retained within the fields. That is, this is the diagram before plowing, this is after the plowing. Fifth. Last point, sixth. Sand is drier soil than clay. This is because holes between the sand particles are not so fine as compared to that of clay as to drop water by capillary action. Sand is drier. Sand is drier than clay. Why? Because you don't have fine capillary action in the sand so that water can move up. So there is no fine hole. Repeat. Capillarity examples. First one is what? Rise of ink in a paper. You place a piece of paper, suspend it in ink, ink will move upward because of capillary action. Towel. In a towel also you have fine pores so that they can soak water. Oil rises in a wick. It is cotton. This is flame. This is oil. Oil moves upward through capillary action and supplies it here, and you can maintain this flame for some time. Fine pores in wood. Yes, in wood also you have fine pores and liquid moves through these pores. Fifth, in a normal field before plowing, you have fine capillary and this water moves upwards. So water moves to the surrounding atmosphere, water is lost. There is a loss of water in the soil. In order to stop this, you plow this field using a mechanical device and you break these. So when you break these capillaries, now there is no rise of liquid and there is no loss of liquid. Sand and clay, comparison of the two. Sand is drier. Why? Because you don't have fine capillaries in sand. Time with waste, 5 minutes to pen down all this.